Okay, so we're going to take a break really quickly. We're going to come back to, actually, those angle relationships, alternate interior, alternate exterior, all that stuff. We're going to come back to that in the next lesson. Before we do that, we're going to talk about proofs. So, with proofs, in math, so far, you have just been told these things are true. If you do this and this, everything is correct and it's true. What a proof is, though, is it tells us why something is true. So if you're trying to explain to your friend how to do a problem and they're just like, well, why is this true? Why are you telling me that I'm going to add these two angles and set it equal to 90? A proof is, well, here's why this is true. What we do in proofs is we take things that we know to be true. So theorems, yeah, even though it sounds like theory, right? Theorems are things we have accepted to be true. They are rules that we use to do all math. Yeah, all math is created by these theorems that we say, yep, these things are going to be true. So what we're going to do is we're going to make a 2-column proof. We're really not going to be focusing on paragraph proofs since we're going to be doing everything online. What a 2-column proof does is it's kind of saying it's the reason or the statement on one side and the reason for that statement on the other. I will say this thing is true and then this is the why. Yeah. So we have some theorems that we can use as we do proofs. We have some properties here. We have what's called the reflexive property. I'm going to get my highlighter here. Reflexive property, which basically says that any statement is equal to itself. Yeah, AB is equal to AB. That's obvious, but it's something kind of important to us. I could also say that AB is equal to BA. Yeah, those are the same things. We have what's called the symmetric property, which says that if one thing equals another thing, if I switch those places, they're still equal to each other, right? Symmetric just means over an equal sign. I can flip-flop those places, and it means the same thing. Transitive property is a bit more confusing. What I like to do for transitive property is I like to think about it like a train, transitive train. We have if AB equals CD and CD equals EF. Notice they are both equal to CD. So CD is connecting them, right? If AB equals CD and CD also equals EF, what happens is then these two are connected by being equal to CD. So they are equal to each other, right? AB is equal to EF. We call that, again, transitive property. If one thing equals something and that something equals another thing, those two things on the ends are also equal. Now we also have just some more definitions about perpendicular lines, complementary, right angles, all that stuff. We're going to be looking at that kind of throughout, but we won't necessarily say theorem 3.1, theorem 3.2. We'll say something a little bit different there. Now to start off with, we're going to be doing the proofs in class, but we want to get used to justifying our reasoning here. So we're going to do this problem. We're going to solve for x. But what we're going to do is think about why. Why am I doing these steps? Why can't I do this, right? So the first thing we need to do here is we need to note what markings we have in the picture. What is this little red marking here on example 1? You have this in your packet. What is that little marking? What does it tell us? We have a right angle. We have a right angle in this picture. The whole thing is a right angle, right? And it's cut, it's sliced, but the whole thing together is a right angle. What do we know about a right angle? What does it measure? That it measures 90 degrees, right? So we know these two angles together give me 90, right? Now, what is that property when I'm saying two angles together give me another angle? What is that? Well, we call this angle addition, actually. You might have forgotten that. I doubt anybody would have remembered. We call this angle addition where I can add this angle plus the angle it's right up against, and that gives me the whole angle, right? So let's write that out. 70 plus x is going to give me the whole angle. So that means I've got 70 plus x gives me the whole angle, which once again is 90, right? So now that we have this equation, now we can just solve for it, right? So how would I solve for x? Go ahead and do that real quickly here. I would subtract 70 from both sides, right, to get x by itself. So x ends up equaling 20. This last step here, we do call this literally subtraction property. That's our reasoning. I can do this because I am allowed to subtract a number over to the other side. So these things right here, these are things that would go into a proof. We got a right angle, it's 90 degrees, angle addition, subtraction property. We're going to talk about that more in class. So I want you guys to try this one, yeah? And same thing, it's going to be basically the same reasoning here. But I want you to take a look at the picture, see the information we have, solve the problem, but also write out the reasoning for why we're able to say these things. Go ahead and try it. It's just like the last one. Okay, so what we know is if two lines intersect to form a right angle, there's also a right angle here. We do have a right angle. Do I want to say if two lines are perpendicular? Yes. If two lines are perpendicular, then they intersect to form 4 right angles. So because there is a right angle right here, this is a right angle, this is a right angle, this is a right angle. We can say that for sure. And again, that's technically theorem 3.3 that we're referencing there. That even though this is the right angle that's marked, guaranteed this is going to be a right angle as well. And again, we know that a right angle is 90 degrees. Anytime we have a vocabulary, we have to define it. So it's not good enough to just say, oh, it's a right angle. We need to say it's 90 degrees. Because if you're explaining it to somebody else and you go, yeah, it's a right angle. They go, well, I don't know what that is. You'd say, oh, that's 90 degrees. Define these things. So with angle addition, we would add my two pieces together. I have x plus 45 is going to give me my full angle 90. And again, from there, we have subtracting x plus 45 equals 90. I can subtract my 45 over. We get x equals 45. So again, this is a basic introduction to a proof. In class, we're going to put it into a 2-column proof, and you'll see again, it'll be here's what I know and here's the reason why. Here's what I know and here's the reason why.